Good morning, dear student. In previous lecture, we will discuss what are the different type of reaction of electronically excited species. That is, one is prompt reaction and second is delayed reaction. In last lecture, we will discuss that is the DD transition. So, how this DD transition is possible by the absorption of light radiation. So, in this lecture, we will discuss the another type of transition, that is charge transfer transition. So, what is this charge transfer transition? What are the characteristics of this charge transfer transition? What are the different types of the charge transfer transition? We will discuss in this point or in this lecture, that is charge transfer transition. So, we already discussed one reaction, that is example for delayed reaction, that is the cobalt complex reaction, that is CO NH35 Cl, it is in +2, and then after absorption of light radiation it is converted into CONH35. It is in +3 oxidation state, and here it is in +2 oxidation state with elimination of Cl. So, this is an example of charge transfer transition. So, if we consider this cobalt is in +3, so in this case it is in +2 oxidation state. So, there is the reduction of metal atom, and if you consider this reaction, so cobalt it is in +3, it is converted into cobalt second. So, it is a charge transfer transition. In this case, the cobalt get reduced to +2 by taking a one electron, that is transferring of one electron from ligand to the metal. So, it is ligand metal charge transfer transition. So, transfer of electron from ligand to the metal. So, this is a ligand metal charge transfer transition. So, before discussing the different types of the charge transfer transition, we will discuss some important characteristics of this charge transfer transition. This charge transfer transition, the first important characteristics of this charge transfer transitions such that these transitions are occur in UV region. These transitions are occur in UV region. If this transition is occur in visible region, then the complex shows very dark color, that is intense color is observed. For example, the dark pink color of KMnO4 is due to the charge transfer transition. So, it is observed in visible region. So, these reactions, these charge transfer transitions are occur in UV region. Second, a redox system, that is these transitions are a redox transition. Charge transfer transitions are a redox transitions. So, what is this redox transition? In this transition, that is in charge transfer transition, one of the component get oxidized and another component get reduced. So, simultaneously oxidation and reduction is going on. Therefore, such a type of transition is called as redox transition. Next, these all transition, that is the charge transfer transitions, all transitions are Laporte allowed and spin allowed transition. Laporte allowed and spin allowed transitions. So, student, we will very much familiar with Laporte transitions and the spin transition. So, for spin transition, the selection rule, that is delta S is equal to 0 for allowed transition, and for Laporte allowed transition delta L is equal to ±1. So, these all transition follows Laporte rule and spin allowed selection rule. Again, if you consider, generally every complexes shows charge transfer transition. Charge transport transition. Almost all complexes shows charge transfer transitions. So these are the some important characteristics of the charge transfer transition. It is generally occur in UV region. The transition is redox transition, means one of the component get oxidized, another get reduced. All transition follow Laporte selection rule and spin selection rule, and almost all complexes shows charge transfer transition. So we will discuss what are the different types of charge transfer transition. So total there are 4 types of charge transfer transition. The first type, that is capital LMCT, it is known as ligand to metal charge transfer transition. Ligand to metal charge transfer transition. Second, that is MLCT, metal to ligand charge transfer transition. Third, that is metal charge transfer transition. It is also known as, or we can write metal charge transfer transition. It is also known as intervalence charge transfer transition. So transition of electron from one metal to another metal, it is known as metal to metal charge transfer transition. And another type, that is ligand to ligand charge transfer transition, that is ligand to ligand charge transfer transition. So these are the main 4 types of charge transfer transition. One is LMCT, second is MLCT, third one is MMCT, that is metal to metal charge transfer transition, LLCT, that is ligand to ligand charge transfer transitions. So out of these 4 types, these whatever the complexes made up by transition metal atom shows these 2 type of transition, that is ligand to metal and metal to ligand charge transfer transition. These transitions are very limited, that is metal to metal charge transfer transition and ligand to ligand charge transfer transition. We are very much interested in this LMCT and MLCT. So let us discuss this LMCT transition, that is ligand to metal charge transfer transition. First, that is ligand to metal charge transfer transition. Ligand to metal charge transfer. Ligand to metal charge transfer. Before discussing what is this ligand to metal charge transfer transition, we will discuss some important points regarding to the charge transfer transition. Charge transfer transition. The charge transfer transition is directly proportional to the number of transition. This is important point, that is the charge transfer transition, it is totally depend on number of transition. So as number of transition is increases, the intensity of charge transfer transition is also increases. It is also depend on, that is the feasibility of the transition. Feasibility of transition. So how easy transition is occur from metal to ligand, ligand to metal, that is nothing but the feasibility of the transition, and it is inversely proportional to the energy difference between 2 orbital, that is metal orbitals and ligand orbital. So the charge transfer transition, it is inversely proportional to the energy difference, that is delta E, between metal orbital and ligand orbital. So let us discuss this LMCT, that is ligand to metal charge transfer transition. So if you consider a metal, So this is ligand to metal charge transfer transition. This is your ligand. So in this case, the ligand having a field orbital and metal having a vacant orbit. Metal having a vacant orbital, and there is a transfer of charge or transfer of electron from ligand to metal, then such a type of transition it is considered as ligand to metal charge transfer transition. So this is field orbital of ligand, field orbital of ligand, and this is empty or vacant orbital of metal, empty orbital of metal. So let us discuss what are the characteristics of the ligand, what are the characteristics of this metal atom. So transfer of charge from ligand orbital to the metal orbital. So ligand orbital should be fully filled while the metal orbital should be empty or vacant orbital. So let us see some important characteristics regarding to this LMCT. So let us consider for ligand what are the characteristics of ligand which shows LMCT, that is ligand to metal charge transfer transition. So in this case, ligand should have a field orbital, ligand should have a field orbital, its energy is high energy, second high energy field orbital, no doubt it required a field orbital, but it required high energy field orbital. Then the next important characteristics of this ligand for LMCT, ligand to metal charge transfer transition, is that ligand should be less electronegative. Ligand should be less electronegative. Ligand should be less electronegative. Then next important characteristics of the ligand which involve in this LMCT, ligand to metal charge transfer transition, that is it easily oxidizable. So we can consider the ligand is easily oxidizable. So the fourth characteristic is that ligand is easily oxidizable. Ligand is easily oxidizable means it easily lose the electron or transfer the electron to the metal orbit, that is ligand is easily oxidizable. So these are the some important characteristics regarding to the ligand. Ligand should have a field orbital, it should have a high energy field orbital, ligand should have less electronegativity, ligand is easily oxidizable. Let us consider for the metal. So characteristics of the metal. The first characteristic is that metal should have vacant orbital. Metal should have vacant orbital, but the orbital is having lower energy. So lower energy. Next important characteristic is that lower energy vacant orbital is available. Lower energy vacant orbital is available. Third, metal atom is in high oxidation state. Metal atom is in high oxidation state. And the fourth important characteristic that it is easily reducible. it is easily reducible. So it will take electron and get reduced, it is easily reducible. So these are the important characteristics of the metal atom, that is metal should have a vacant orbital, low energy vacant orbital, metal atom is in high oxidation state, it is easily reducible. Another important characteristics regarding to the metal which is involved in LMCT, ligand to metal charge transfer transition, is that it should have low principal, it should have low principal, it should have low principal quantum number, it should have low principal quantum number. That is, if we consider 3D, 4D, 5D, then for LMCT, for effective transition, that is ligand to metal charge transfer transition, so metal should have metal should be from 3D series. So these transitions are very intense transitions, so it should have low principal quantum number. So these are the important points regarding to the LMCT. If we consider how this LMCT is occur, or how this transition is occur, that is, if we consider this is your metal orbital, this is your ligand orbital, and this transition is takes place, that is transfer of charge or transfer of electron, and this difference it is considered as delta E1. The energy difference is very high in this case, so it required large energy for transition, that is transfer of electron from ligand orbital to the metal orbital. For effective transition, this ligand increases its energy, it increases its energy slightly. So this is your ligand, and for effective transition, this metal it will decreases its energy. This is your metal, and due to this the energy difference is decreases. Due to this the energy difference is decreases. So let us consider this is delta E2. So due to decreasing the energy difference, the intensity of the transition is increases. So we know that is the transition, charge transfer transition, is inversely proportional to the energy difference between two orbital, that is ligand orbital and metal orbital. That is, as the delta E is increases, charge, the intensity of charge transfer transition is decreases. So in this case the energy difference is very high, and therefore the intensity of charge transfer transition is very weak. But in this case, if we consider the difference, that is delta E2, the delta E2 is very small. So as the energy difference is decreases, the intensity of charge transfer transition is increases. So if we consider a metal atom, for if you consider the energy difference, that is, this is for metal orbital, this is for a ligand orbital, then the energy difference, that is delta E, this is for 5D. Then if you go, then this is for 4D, this is metal and this is ligand, the energy difference. And if you go further, that is 3D, then the energy difference goes on decreasing, that is delta metal and ligand. So one of the characteristic of the metal, that is it should have a low principal quantum number. So as principal quantum number is decreases, the difference between two orbital, that is energy difference, is also decreases, and the intensity of the charge transfer transition is increases. The intensity of charge transfer transition, that is ligand to metal charge transfer transition is also increases. So this is regarding to the principal quantum number. As the second important characteristic is that as oxidation state of metal atom is increases, then the energy difference is decreases. So if you consider the difference, this is your metal orbital, this is your ligand orbital. So this difference, that is delta E for zero oxidation state is 0 in this case. Then if you go further, then the energy difference, that is for +1 oxidation state, and if you increase the oxidation state, that is metal atom is in +2 oxidation state, again the difference goes on decreasing, metal and ligand. So as the oxidation state of metal atom is increases, the intensity of LMCT is also increases. Again we will discuss the important characteristics regarding to the ligand which is involved in the ligand to metal charge transfer transition. That is, the ligand should have a low electronegativity. Then if you consider the electronegativity, the energy difference, that is this energy difference delta E, this is metal orbital, this is ligand orbital. So in this case the ligand is fluorine. Again you go further, then the energy difference is decreases. So in this case the ligand is bromine, this is your metal and this is your ligand orbital. Again we go further, the energy difference goes on decreasing. So in this case the ligand is iodine. So this is your metal orbital and this is your ligand orbital. So this is the effect of electronegativity of ligand. So as electronegativity of ligand is decreases, the charge transfer transition, that is intensity of ligand to metal charge transfer transition, is also increases. So this is regarding to the LMCT, that is ligand to metal charge transfer transition. In next lecture we will discuss the second important type or second important transition, charge transfer transition, that is metal to ligand charge transfer transition. Thank you.